Hello, this is FlippedHarber for Algebra 2. In this video we'll be covering section 2.5, linear inequalities in two variables. Our objectives for this lesson are to graph linear inequalities on the coordinate plane. We also want to solve problems using linear inequalities. The topics that we're going to talk about will be linear inequalities and boundary lines. So first of all, a boundary line is basically a straight line on our graph that splits the graph into two regions. The values where y is greater than the mx plus b of the line, and the region where y is less than the mx plus b for that line. Now the y greater than is always above the line. Literally, the y values are greater when they're above in the graph. The region below the line is where y is less than. It always works that way. Now let's graph the linear inequality y is less than 1/2 x plus 1. The first thing we want to do is graph the boundary line. Our boundary line this time will be dashed because y is less than the mx plus b. Whenever you have y is less than or greater than, it's a dashed line. If y is less than or equal to, or if y is greater than or equal to, that boundary line will be a solid line. Since we don't see the or equal to, our line will be dashed. Then what we're going to do is test points on each side of that line, and then we'll shade the side where the test points work. Alright, let's get started. First thing we do is find 1, that's our b value, that's our y-intercept. We use a slope of 1/2, that is that we go up 1, right 2, we mark the point, and we draw the straight dotted line through them. Now, if we pick a point on either side, doesn't really matter which side we pick, I always like to use a nice easy number like 0, 0. As long as the boundary line doesn't go through 0, 0, I like to use it as a test point. If I plug in 0, 0, that is I'm plugging 0 in for x and 0 in for y, I find out that the point works because it becomes 0 is less than 1, and that's a true statement. Since 0, 0 works, that means that every point on that side of the line will work, so that's the side that I shade. Now, if we want to graph the linear inequality 2x plus 3y is greater than or equal to 6, probably the best way to do it is with intercepts. It's easy to find intercepts when it's in this standard form like this. General form like this. We're going to find each intercept, both x and y. We'll use those intercepts to draw the boundary line. Now this boundary line will be solid because it's greater than or equal to. Whenever you see that or equal to, our boundary line is a solid line. And then we'll shade. Now how do we know which side to shade? Test points. We'll choose a point, probably 0, 0, and see if it works. So let's do that right now. If we plug in 0, 0, we end up with 0 is greater than or equal to 6. Well, that's not true. 0 is not greater than or equal to 6. So we're going to shade the side of the line that doesn't have 0, 0. Alright, what about finding our x and y intercepts? Well, just like an equation, the way that we find our x-intercept is we plug in 0 for y, and we get x equals 3. To find our y-intercept, we plug in 0 for x, and we get y equals 2. So, our y-intercept is 2, our x-intercept is 3, we draw a solid boundary line, and we don't shade the side with 0, 0 because we tested 0, 0, it did not work. So that whole side does not work. Well, that means that the other side does. So we shade above our boundary line. Now, let's graph this inequality. Y is greater than or equal to 2. It's not really in slope-intercept form. Well, what would a line y equal to look like? Well, if y equals 2, that's a horizontal line at 2. Now, are we going to shade above or below it? We shade above it because y is greater than or equal to 2. Notice that our boundary line is solid. Again, our boundary line is solid whenever we see that or equal to in our inequality. Let's solve the inequality and graph. Now, when we say solve and graph, basically what we're trying to do is get it into slope-intercept form. Get the y alone on one side. Now, the first thing I'll do is divide the 2 over. Yes, I could distribute it in, but if I go ahead and divide it over, it's gone, never to be dealt with again. Subtract the 3x over, and then finally divide by that -4. Now pay close attention to that inequality sign. When I divided by the -4, that inequality sign flipped. So it's read y is less than 3/4 x, 3/4 x, minus 3. So I know that my slope is 3/4. I know that my y-intercept is 3. Because y is less than that, I'll draw a dotted boundary line, and I will shade below that boundary line because y is less than. So there we go. That's what it should look like. We've got the y-intercept -3. We use our slope of 3/4, which means that we go up 3, right 4, draw a dotted boundary line, and we shade below. All right, that's it. You've got the homework. It's time to get to work, and I'll see you in class, and I'll see you online.